I'm going to solve this one by getting a common base. 81 is 3 to the 4th. 27 is 3 to the 3rd. So this becomes, I can drop the 3's while I can distribute the powers. I distribute these powers, so it's 4x plus 4. And this is 6x. You multiply those, and I can drop the bases now. The 3's don't matter. Then I just solve. I subtract 4x from both sides, divide both sides by 2, and this gives x equals 2. That means that 81 to the 3rd is the same as 27 to the 4th, and you can plug it into your calculator and check if you want. Is there a question about number 1? Can we do number 2? Make any progress there?
I got number 2.
Go for it, Max.
It was a lot of help from Bree because she realized, okay, that 1/2 is really 2 to the negative 1.
I'm gonna kill Bree. What's 16?
It's 2 to the 4th.
Ah, nice work, Bree.
Well, that was on me.
I doubt that.
all.
Distribute this 4, so 4 times x minus 3 is 4x minus 12. And then when you solve, oh, there's an x here.
Yeah.
Excuse me. Then when you solve, we're going to get negative 5x equals negative 12, which means that x equals 12/5. A lot of people are getting that wrong because they're just getting lazy with their solving. Subtract 4x from both sides to get negative 5x, and divide both sides by the negative 5, and that's where you get 12/5. Question number 2 at all? Max, you also wanted number 3?
Yeah, just because I don't really understand it.
Okay. I'll plug 4 in for x, we'll start there.
Yeah.
So I have log base 2 of 4 minus 2.
I got it to 2.
How'd you get 2?
It's 4 minus 2 is 2.
No. The question is, 2 to what power is 4?
2.
2 to the 2nd power is 4. So this whole thing right here is really just 2.
Okay.
So it's 2 minus 2, which is 0.
See, that's where I went wrong.
Right, the very first step.
Very first step.
Okay. So this next one is very similar. I'm plugging a 4 in for x. I'm doing log base 2 of 4 minus 2, which is log base 2 of 2. So the question here is 2 to what power is 2? And that's 1. 2 to the 1st power is 2. So that all works out to a 1. So whenever you see a log, it's really asking the question, the base to what power is the number in the parenthesis? That's what it's asking. So if we did log base 3 of 81, well that's 4, because 3 to the 4th power is 81. Are you telling me what log base 5 of 125 is? It's 3. Because 5 to the 3rd power is 125. So Nick, were you the one on the right? Okay. And how'd you get negative 3?
Log 5 over 1. And then negative 3.
Beautiful. Good. And the thing that I remember is this is not a fraction, and this is the reciprocal in here. So to go from 5 to 1/25, to go from the not a fraction to a fraction, we need to do a negative power. Whenever a fraction is flipping of any sort, you're going to use a negative power. Okay, going on down, 1/5 to the 120, log base 1/5 of 125. Who had this one? Okay, Josh?
I don't have that.
Oh, okay. If only we hadn't been talking the whole time, that might have helped. How about this, Josh? 5 to what power is 125?
3rd.
Good, 5 to the 3rd. So 1/5 to the negative 3rd would be 125. There. Well, what does a negative power do? Flips the fraction. Right, a negative power is like a reciprocal. It flips the fraction. So if 5 to the 3rd is 125, 1/5 to the negative 3rd is 125.
Okay.
Does that still not make sense?
Now I kind of get it a little bit.
The negative flips the fraction. And then 5 to the 3rd is 125.
Okay.
Okay. One more. Bradley, is this you?
Yeah.
Have at it. 3. 1/5 to the third is 1/25th. Anybody any questions on that at all? So the hope is, the goal is you tried homework 11. You got as far as you could on homework 11, but there are some things you couldn't quite handle, which is why we're doing 2-day assignments again, because you need to go home and try it, and then we come back the next day and we talk some more about it, and it starts to make more sense, and then it's due the following day. So we're going to talk about graphing now. We just went over evaluating logs and simplifying logs, now we're going to graph a little bit. When you're graphing, the main question you have to ask yourself is, what should I plug in for x? What should I plug in for x? That's the question. Well, remember that with logs, this here is really saying 5 to what power is x? So I want to worry about powers of 5. I'm going to plug in powers of 5, like 1/5, and 1, and 5, and I can think about 25. I can't graph 25 on my graph, it's too big, but I can still think about how it's going to work. So here's what I mean. If I plug a 5 in for x, five to what power is 5? 1. So this just equals 1. That means that the y value is 1. So this is the point, 5, 1. Let's plug in 1. What if I do y equals log base 5 of 1? Well, 5 to what power is 1? Yeah? 0. 5 to the 0 power is 1.
You get 0.
Anything to the 0 power is 1.
Oh. That's pretty clever.
25? Anybody? 5 times 5 is 25, so it's 5 squared. 5 to the second power. So that leaves us with 1/5. Log base 5 of 1/5. Well, 5 to what power is a fifth? Negative 1. So I have the point 1/5 negative 1, which is basically there. 1, 0. 5, 1. And 25, 2 I can't put on my graph. Then I've got this asymptote over here. My curve goes like that. And the asymptote is at the line x equals 0.
Without graphing that, how would you be able to determine what the asymptote is?
H. We'll see an example in a second where whatever's in here with the parenthesis is what determines where the asymptote is. We'll do one more example that you'll see that.
Okay.
Let's go back to this question here. In general, what should we plug in for x?
Roots.
Not quite roots, like what you're saying, yeah?
Did you say powers of whatever, like, of the base?
Powers of the base. Plug in powers of the base for x. 1/5, 1, 5, 25. Okay, so let's talk about this one. It still has the log base 5. That's not changing. But now I've got stuff inside a parenthesis, and something that I'm subtracting, and something that I'm multiplying. So there's a lot more going on. But I still want to get this parenthesis here. I want x plus 1 to equal powers of the base. I want it to equal 1/5, and 1, and 5, and I can think about 25, although that's again too big. I'm picking these numbers because these are all powers of 5. Okay, so this is just like we did with square roots. With square roots, we took whatever was inside the radical and set it equal to 0, 1, 4, 9, 16. So those were perfect squares. Well, now we're taking whatever's inside the parenthesis and setting it equal to powers of the base. Powers of the base. Now I solve. When I solve this, I'm going to get x equals negative 4/5, x equals 0, x equals 4, and x equals 24. This is the x column of my squirrely table. Okay, is this making sense so far? Got 3 people nodding their head and the rest kind of staring at me. Are we doing okay? Okay. Well, let's plug in negative 4/5. Annie, what's negative 4/5 plus 1? It's a fifth. Right, because the point is, whatever we plug into this is going to come out to one of these numbers. That's how we set it up. So negative 4/5 plus 1 is 1/5. So what's log base 5 of a fifth?
Negative 1.
Negative 1. This whole thing here equals negative 1. What's negative 1 times 2?
Negative 2.
Minus 2? Let's plug in 0. Somebody else. Spring, what's 0 plus 1?
1.
I gave you the easy one. Sorry, Andy. 5 to what power is 1?
0.
Good. What's 2 times 0?
0.
Minus 2?
Negative
Sweet. Somebody else will do 4. Joe, what's 4 plus 1? What's log base 5 of 5? 1. 5 to the first power is 5. So this is a 1. This whole thing is a 1. What's 2 times 1?
2.
Minus 2. And you're probably seeing now that since we picked these numbers very special, that's going to be a 2. 24 plus 1 is 25. That becomes a 2, 4, 2. So I have negative 4/5, negative 4, 0, negative 2, 4, 0, and then 24, 2 I can't fit. Max, where's my asymptote now?
Negative 1.
X equals negative 1, which we could have found
Huh.
here.
Look at that.
Look at that. X equals negative 1. That's our h value. Now with exponentials, it's k. If we have this, we have this, y equals 2 to the x plus 1 minus 2. That would be the exponential, or the asymptote of an exponential function. Max, I'm talking to you.
I'm listening very
Okay.
good. Asymptote of an exponential function. Max, I'm
Yeah.
talking to you.
Yeah, very nice. Okay, is there a question about that at all? Does that make any more sense? Feel any better? Okay, wonderful. Here's our new stuff. Although this isn't really super new, actually. We've basically been doing this already. We're going to solve equations. We have to know what x equals. We can find x values that make these things true. This right now is written in logarithmic form. Oftentimes, converting to exponent form is really all you have to do. So when you're solving, the goal is to get the x by itself. Right now that x is kind of buried in that log. If I convert, if I say 8 to the 2/3 equals x, I get the conversion from log form to exponential form. Well, now the x is by itself. What is 8 to the 2/3? Without your calculator, anybody? It's 8 times 2/3.
64 over 3.
Mhm.
4.
Why is it 4?
Because it's like 2 times 2, and then like 8 is 2 to the 3rd. So it'd be 2 to the 2 would be the fact.
Sure. A little easier. The third root of 8 is 2, and 2 squared is 4. You're doing divided by 3, not third root. Trevor, it's third root. So x equals 4. Now that you can do in your calculator. 8 to the 2/3 you can do in your calculator. How about the one on the right? Can you tell me how we're going to attack this one? Yeah? I love it. We can just drop the logs. Because these are the same, if this is a true statement, logically this has to be a true statement. And the only way the top statement is true is if the bottom statement is true. So we can just drop the logs. When there's a log on both sides, a single log on both sides, you can just drop it. Now, I'm going to solve this like regular. Subtract 2x and add 2.
Would this work if there weren't parentheses?
No. You could quadratic formula this, but that would factor it. We factor and we get solutions of -2 and -1. Now, unfortunately, gosh dang it, you have to check. These might not work. Extraneous is an option. Extraneous is going to be an option for pretty much the rest of your mathematical careers. I'm sorry. We can't just trust the answers anymore. Let's plug in -1 and see if it works. I'm going to check this one first. If I do log base 8 of -1 squared plus 5 times -1, and I want to see, does that equal, that's what that question mark means. I'm asking the question, is this equal to log base 8 of 2 times -1 minus 2? Well, this becomes log base 8 of 1 minus 5 is -4. What is log base 8 of -4? Not possible. 8 to some power can't be -4. There's no way to get 8 to some power to equal -4, so this isn't possible. And for the same reason, this isn't going to be possible. These are both going to come out to negative numbers. Neither of these work. This has no solutions. Yes, Mitchell? Not really. You say in your calculator, that you said? You can always graph it like I showed before. You don't know how to graph this yet unless you have a fancy calculator. I'll teach you eventually. 84 silver plus could maybe do it. Maybe, I'm not sure. Depends on if when you press the log button, if it gives you a little box down there to type things in, you can do it. If not, I'm going to show you how to eventually either way. But right now you probably can't. Okay, so here, on the right side, we dropped both logs because we knew that if this was true, this had to be true. Then we solved. In this case, we solved by factoring, but you could use the quadratic formula. Then we plugged them in and we checked. And I know you can't plug this into your calculator up here. You can't do that in your calculator, but you can still reason through it. It should come out to numbers that work out pretty nice. Question about either of those? Most of the first half of your homework looks like both those types of problems. One on the left, you just convert. One on the right, you can drop your logs. Beautiful. On the left side here, I have properties of exponents. Let's review. B to the A times B to the C is B to the A plus C. B to the A over B to the C is B to the A minus C. And B to the A to the C is B to the A times C. We've done that a couple times in this class already. But what I've said over and over and over is that logs are exponents.
What's the log stand for?
It stands for logarithm, and one of these days I'll explain really well what we're doing and why we're doing it. We're like just 2 days away from just kind of wrapping it all up real nice and pretty. So just hang on for a second.
You have to go up a little bit.
Yeah. If I have 3 to the second equals 9, well, that means that log base 3 of 9 equals 2. Well, here, this whole entire log is the exponent 2. The log is actually the exponent, which means that logs follow the same properties of exponents. And they're kind of written backwards. But if you have log base b of two things being multiplied, you can split it up into addition. So that means that I have log base b of a plus log base b of c plus log base b of a times c. We're going to go both directions. We're both going to split up and we're going to combine. So if I have log base b of a minus log base b of c, that's log base b of a divided by c. And the third one is the weird one, but the really, really useful one. If I have a coefficient being multiplied in front of a log, I can pull it up as a power. That's the one that we're really going to rely on the most. That's the useful one. These two used to be absolutely critical. Like, there was a time, back to my grandparents, probably my parents, had to be able to use those two properties like crazy. But now that we have calculators, we don't really need them anymore. They're still sometimes been useful, though. They're still worth running. Okay, here I have two logs that are being added. So they can simplify with multiplication. That becomes log base 2 of 15. Here I have two logs that are being subtracted. Well, subtraction, by this property here, turns into division. So I'm going to do 12 over 2, so it becomes log base 6 of 6. And that can actually simplify further. Log base 6 of 6 is 1, because 6 to the first power is 6. We can't do log base 2 of 15 yet. We'll be able to eventually. Yeah?
So for this to work, the bases have to be equal.
They do. That's why these are both B's. It's not B and C. They have to be the same base. What's the base of this one?
1.
Nope. 10. Okay, there's no base for it, it's base 10. Max 1 is a good idea, but it can't work. 1 to what power is 12? Well, we do know it's not possible. Because 1 to any power is 1.
Oh.
Right? 1 to the 5th power, 1. 1 to the 30th power, 1.
Okay.
Yeah, so it can't be 1. That's why we do 2 as our kind of parent function. So it can't be 1. First thing I'm going to do, because of this property here, go with some other color. So this property here, I can pull 4 up, and I could do negative 3 or positive 3, doesn't matter. I'm going to keep it a positive 3 for now. So I have log of 2 to the 4th minus log of 2 to the 3rd.
What's the number that you don't see on the log?
10, space 10. Yeah, we didn't get there, did we? Space 10. So this means that the log of 16 minus the log of 8. Well, the final property is that subtraction turns into division. So now it's log base 10 of 2.
Why didn't you write the 10 in?
Because 10 is what we're almost always doing with logs. So we assume that there's no base written, it's base 10. Your calculator has a log button, it's doing log base 10. Max, you should watch the videos when you're gone on Fridays. What was that?
I said I plan on it as soon as we get home.
Then what happens?
No, I mean,
Are you both today?
that's what you're gonna do.
Were you gone like all weekend, like doing stuff?
I was gone for a good portion of the weekend, and then when I came back, I just wasn't there literally doing work.
Yeah. Okay, now we can simplify and solve. Here on problem 1, I cannot just drop the logs, even though there's logs everywhere, because there's multiple logs on one side. I can't just assume I can drop the logs and say 3 plus x equals 9. It doesn't work that way. It's not that simple. I can drop the logs if I combine it down into one log on either side. So addition turns into multiplication. This is log of 3x equals log 9. Because of the properties on the last page, these numbers here, 3 and x, multiply together. Now I can drop the logs, and I get that x equals 3. Yeah, but sometimes it won't be, and we have a system we can follow. Yeah, Mitchell?
Will it always be a physics addition and combine in one log? So if it's like log of 3 plus log of x plus log of 2 equals log of 9, you combine it all of 6x.
Yeah, so he asked, what if there was also like a log of 2 out here? I would make this log 6x. Yeah. Over here, I'm going to pull up this 2 as a power and pull up this 3 as a power. So I have log base 4 of 9 equals log base 4 of x to the third. I got 9 because 3 squared is 9. Drop the logs. 9 equals x to the third. What do I do now?
Cube root.
Third root both sides. X equals whatever the cube root of 9 is. I don't really care what that is. X is the cube root of 9, which isn't 3. Last one. I'm going to pull this 2 up as a power. So I have log base 2 of x squared minus log base 2 of 4 equals 3. Now the subtraction turns into division, which I know sounds weird when I say it, but that's what's happening. So I have log base 2 of x squared over 4, and that equals 3. That's why I like to use parentheses once these get messy. I'm trying to solve this for x. Let's try to do next. Two to the third. Good. Convert. 2 to the third equals x squared over 4, which means that 8 equals x squared over 4. Multiply both sides by 4. 32 equals x squared. Take a square root of both sides to undo the square. And I'm going to get, this simplifies into 4 root 2. I just simplified the square root of 32 into 4 root 2. And what am I forgetting? No, but I should. That's what I'm forgetting.
Plus or minus?
Plus or minus. Only one of them will work, probably. Definitely. In this case, only one of them will work. So you have to check both and see which one it is. Yeah?
What do you call it?
They both work. That can't ever happen here. That'll never happen here. That is possible on these ones.
Would you get the 2/3?
What 2/3?
2/3 equals x squared over 4.
2 to the third. We converted. 2 do the circle thing. 2 to the third equals x squared to the 4. Does that make sense? Like when I have this, that becomes this. Do the same thing. Converting is often the key to solving. It's usually the real critical piece. Okay, is there a question about this at all? Sweet. We'll have a quest on Friday. Write that on the board. And that should take care of you for tonight. You should